Today we're going to be discussing how the forest community in Point Pleasant Park recovered after Hurricane Juan hit Halifax, Nova Scotia in 2003. In 2003, Hurricane Juan devastated Point Pleasant Park in Halifax, Nova Scotia. This storm caused huge mortality rates in trees and plant species, which caused a major alteration to the forest composition. Due to this storm, long-term monitoring has been put into place starting in 2004 up to 2026, excluding 2005, 2007, 2016, and 2020 to see how the forest recovers. Because Point Pleasant Park is an urban forest, it may recover differently than what is expected from a natural forest. This means that successional trajectories may not always be predictable due to other urban factors influencing the forest community. Putting all these factors together allows us to study how the overall forest community has changed over time since Hurricane Juan. Using succession theory, we were able to hypothesize that overall diversity would increase over time, and the forest community would transition between mid and late succession to become more stable.
Methods. So data was collected by Biology 2060 students from 2004 to 2025, excluding the previously mentioned years where collection was not possible. And so in 6 20-meter by 20-meter sites in Point Pleasant Park, Halifax, Nova Scotia, study sites were selected based on surveys which determined the most hurricane-impacted areas of the park. And so using diameter breast height measurements, DBH, which is approximately 4.5 feet off the ground, all living trees within each site with DBH greater than or equal to 2.5 centimeters were measured using a diameter measuring tape and counted using the Trees of the Acadian Forest Identification Guide from Nova Scotia Department of Natural Resources. And then after data collection, regression analysis was used to plot changes of tree species density and biodiversity over time after Hurricane Juan. And this type of analysis is useful for this data because it tests and visualizes the strength of the two variables and their relationship over time. So we can see the increasing or decreasing trends. We were also only comparing data from the same sites, so our variables are staying the same throughout the whole experiment.
This graph shows how the overall forest community has changed over time since Hurricane Juan between 2004 and 2026. The Shannon Diversity Index was used to measure community structure. There's a positive linear relationship shown between the year and diversity. This demonstrates the overall increase in diversity within the forest community, and the increase in diversity most likely shows secondary succession. This could be due to an increase in species present from 2004 before the hurricane to 2026. Due to the increase in population, the community will most likely stabilize as competition increases.
So how has the dominant species density changed over time from 2004 to 2025? So the dominant species in 2024 was the red spruce, with an average density of about 3.4 trees per 400 meters squared, which is shown on the graph on the left. And then in 2025, the dominant species was the red maple, which has an average of 30 trees per 400 meters squared, and that's in 2025. So starting on the graph on the left for red spruce, the regression analysis shows a positive relationship between the density and time, and an increase from the 2004 average of 3.4 to the 2025 average of 8.6 trees. Indicating that red spruce density increased over time after Hurricane Juan. And this is similar for the graph on the right as well, which shows the red maple density, which also has a positive relationship over time after Hurricane Juan. However, the red maple density shows a much greater increase from an average of 0 trees to 30 trees from 2004 to 2025. So why is this density and dominance changing? So red spruce was the denser species in the years immediately following the hurricane, about 2004, and stayed quite consistent until around 2009. However, starting in 2009 and continuing until 2025, red maple surpassed the density of red spruce and became the dominant species. This is largely due to the growing times of the two species, where red maple has a faster growing time and was able to bounce back and dominate the density, whereas red spruce is slower to grow and so was not seen as much in the first successional community and was surpassed by the maple as they were generated after the hurricane. Also, the larger densities make sense as the forest community recovers over time. So we see a greater increase in tree growth.
So expanding from the last slide, what can we predict will happen to the dominant species as the forest moves towards its climax community? So as the forest moves towards its climax community, which is its relatively stable state, we will likely see red spruce density increase and potentially out-dominate red maple after it's allowed enough time to reach its full growth potential. The differing lifespans of the two species should also be taken into account, as even though red maple grows faster, it only averages about 100 years, while red spruce averages about 400. And so red spruce, in the long run, is likely to become the dominant species. Additionally, based on the 1998 ecological survey of Point Pleasant Park, so pre-hurricane, red spruce was the long dominant species, so it's likely that the red spruce would be able to return to dominance given the right growing times and conditions.
To understand the effects of Hurricane Juan on species richness in Point Pleasant Park, data was gathered comparing species richness over time in 5 different 400 square meter sites. There is a strong positive correlation between species richness and time, with species richness increasing over time. The results show that species richness is increasing each year, implying that the species richness is recovering from the after effects of Hurricane Juan. It's evident that species richness has been climbing after Hurricane Juan. As the forest approaches its climax community, I predict species richness in the coming years will drop by a little and then plateau as the forest stabilizes. After a hurricane in North Carolina, a Piedmont forest experienced an increase of exotic species and no decrease of original species. This is due to the new niches created by the hurricane. Shade-intolerant plants are able to grow without the presence of a large tree canopy, further increasing the richness of the area. A study done by Tersch in 2016 also saw an increase in species richness. They predicted that before the hurricane, the forest was approaching or at its climax community, and the new niches allowed richness to grow. It is hard to determine whether these new niches will remain present or not. If these new niches are replaced by the recovered pre-hurricane ecological conditions, then we can expect loss of species adapted to these conditions.
So, how do invasive and non-native species in places like Point Pleasant Park react after disasters like Hurricane Juan, and how does this affect the secondary succession of the species in the park? So, after such disturbances, like the hurricane, invasive species can colonize an area at a fast rate and interrupt the expected succession of the native plants. The exact mechanism which invasive species do this is not fully understood yet and requires more research. However, current researchers attribute the increase in invasive species in disturbed areas to firstly the increase in resources in an ecosystem after other plants are destroyed by disturbances. Also, the ability of the plants to grow fast and establish themselves early in succession, and certain physiological traits which make them more resilient and able to withstand greater stress. And so this affects secondary succession, which is the restoration of organisms after disturbance where the soil is still intact and nutrients are still available. And the invasive species have a big effect because they can establish themselves before the native species, creating greater competition and less chances that the native species will be able to establish and not be outcompeted. And this could lead to less diverse communities, which decreases a community's resistance to disturbances and further supports the growth of invasive species.
Due to Hurricane Juan, there was loss of canopy coverage, which allowed fast-growing and fast-reproducing R-selected species to outcompete the slower-growing species in the forest. Because of the increased levels of sunlight available to the forest, these R-selected species are usually able to take advantage of this abundance of light and become more dominant. As these species grow, they slowly recover the forest canopy, meaning that the amount of sunlight available to the rest of the forest is decreasing. This allows the K-selected species to redominate the forest and recover the original stable community that was present prior to Hurricane Juan.
As Point Pleasant Park approaches its climax community, an increase in frequency and intensity of storms would have dramatic effects. The forest has been recovering for more than 20 years. A storm of equal magnitude would completely reset this progress, and a storm of higher magnitude could send us further back than where we started. Although this would be devastating, given enough time, the forest will recover, as we have seen. However, if the storms become more frequent, the forest won't have the time needed to recover. These frequent and intense storms would inhibit Point Pleasant Park from reaching its climax community. The forest might become unstable, similar to how the most abundant tree changed from red spruce to red maple after Hurricane Juan. Further hurricanes could cause other species to become more dominant or less dominant. This continuous flux would cause instability and not allow niches to establish. Hurricane Juan devastated Point Pleasant Park in 2003, destroying the forest. This caused many key ecological features to be lost. The forest is currently in the mid-successional stage and is approaching late succession, as supported by Shannon diversity, species richness, and the number of red spruce and red maple trees, which are all increasing. The fact that this forest is urban and being treated by management plans, such as removing dead trees and protecting juvenile trees, allows for. We would like to say thank you to Dalhousie University, Joanna Zagura,